Let's look at the solutions of quality quant questions, week 25, questions around circles. In the given figure, measure of arc PAS, this arc is equal to measure of arc SBQ. Okay, so if I take this as the center, this point as the center, we are told chord PS, arc PAS is as good as chord PS, is equal to chord SQ. And if they are equal, the angle that they subtend at the center will also be identical. So let's say the angle subtended here is X, the angle subtended here is X. Arc PCT is equal to arc TDR. Okay, that means chord PT is same as chord TR. So the angles subtended by these two chords are also going to be identical. Let's say this was Y and this was Y. Now measure of QPR, angle QPR is 15, which would mean this center, angle subtended by chord QR at the center is going to be twice of that, 100 degrees. Find the measure of UVR. We are looking for this angle. So instead of calling it UVR, I am calling it SVR. Now this is the angle framed upon intersection of chord PR and chord ST. If we are looking for measure of angle formed upon intersection of chord PR and ST, we look at arcs PCT and arc SQR. Look at these two arcs. The angle subtended here, this angle will be equal to half of measure of arc PCT plus measure of arc SQR. Now PCT subtends an angle of Y at the center and SQR subtends an angle of X plus 100 at the center. Additionally, know this, angles around the point add up to 360. 2x plus 2y plus 100 is equal to 360, or 2x plus 2y is equal to 260, or x plus y is equal to 130. That enables us to get the measure of y plus x here. So we get half of 130 plus 100, or the final answer being half of 230, which is equal to 115 degrees. Or option C is the right answer. Next question. A, B, C, E, and F are points on a circle as given in the figure. FG is 5. This length is 5. AG is 8. This length is 8. BG is 24. This length is 24. ED is 7. This length is 7. And CD is 5. This length is 5. What is the length of BC? We are looking for length of BC. Now BC is part of this secant DB, and DA is also another secant. DB is a secant, DA is a secant. So we know DE into DA will be equal to DC into DB. This is the final equation or expression that we have to worry about. Now DC I know to be 5. DB I know to be 5 plus BC. Right hand side, length of BC is what we are figuring out. So we know that. DE we know is 7. Now DA however is EG plus AG. AG we know to be 8. So we can actually replace this AG with 8. So in order to get to BC, I need to figure out the length of EG. Now EG, look at these two chords, FB and EA. These are two intersecting chords, which would imply FG into GB has to be equal to AG into EG. So FG is 5, GB is 24, AG is 8. So you can get the measure of EG. EG will be equal to 15. Once we have found our EG, we can replace it here. we will get uh, oh, I have made a mistake. dA is not just EG plus this. This is, wait, let me write it properly. DE plus EG plus GA plus GA. So I know the measure of DE, that is 7. I know the measure of EG, that is 15, and I know the measure of GA, that is 8. So 7 plus 8 plus 15, 30. So we have 7 into 30 is equal to 5 into 5 plus BC. Cancel 6. We get 42 is equal to 5 plus BC. So BC is equal to 37. And this will be it. Final answer. Next, in triangle ABC, let AB is equal to 20 centimeter, AC is equal to 11 centimeter, BC is equal to 13 centimeter. The diameter of semicircle inscribed in ABC, whose diameter lies on AB and sides AC and BC are tangents to the semicircle, is equal to. Okay. So the triangle will look something like this. This will be 20. This is 13. This is 11. And the semicircle that gets formed will be like this. Now let's say the center of the semicircle is here. This is A, this is B, this is, sorry, AB is the longest one, no? So this is A, this is B, this is C. A, B, C, this one. Now we are looking for diameter of this semicircle. Right now I'm connecting, I'm calling this point M, I'm connecting C to N. Now, given that BC is tangential, this point MN and MP, point P, these will be 90 degrees here. These will be 90 degrees here. So area of CAM will be half into CA into the radius of the semicircle plus the area of triangle CMB. CMB will be half into CB into the radius. And these two triangles together will be equal to the area of the entire triangle. Now, area of the entire triangle, while all three sides are known, is generated by the Heron's formula, which is S into S minus A into S minus B into S minus C. So, see, CA is known, CB is known, and every term on the right hand side is known. The only unknown left in this expression is the radius. So we can proceed. So we will have half of 11R plus half of 13R is equal to, now S is semi-perimeter. Semi-perimeter 11 plus 13 plus 20 is 44. 44 by 2 is 22. So we get 22. 22 minus 20 is 2. 22 minus 11 is 11. And 22 minus 13 is 9. So we get two 22s and two 3s. So this right hand side is equal to 66. Left hand side, half of 24 is 12R. 12R is equal to 66. Now, finally, the question asks me diameter of the semicircle. So I need 2R. So in order to get to 2R, I need to divide this by 6. I also need to divide this by 6 so that the equation maintains. We get 2R is equal to 11. And that should be the answer to this question. The length of the diameter of the semicircle will be 11. In the figure, ABCD is a square of side A. What will be the area of the shaded region? AD is equal to AC and F is the center of the circle. Now, if this is a circle and square is inscribed in it, know that all these segments will have equal area. So first thing you have to do in order to get the area of the shaded region is get this area of this segment. And then from that, remove the area of triangle EGH. Okay. So area of the segment, if I have to figure out, first I need the radius of the circle. Radius of the circle, see, these center of the circle will also be the meeting points of the diagonal for the square. So if this is R, side AB will be equal to R root 2. R root 2 is equal to A, or R is equal to A by root 2. This is known. Now, I know the radius. I know the area of the square. So I can get pi A square by 2 minus area of the square, which is A square itself. I can get pi A square minus 2A square whole thing by 2. I can take A square by 2 out. I'll be left with pi minus 2. Now I need area of triangle EGH. For area of triangle EGH, I need the length of GH, I need the length of EJ. EI in total, EI will be EJ plus the side of the square, JI is equal to side of the square. And EI is also equal to EF plus FI. See, this length will be equal to half the side of the square, A by 2. And this length will be equal to the radius. And this is also equal to EJ plus side of the square. So I can go EI is equal to A by root 2, radius of the circle, plus A by 2. And it is also equal to EJ plus side of the square. So this will give me root 2 plus 1 by 2A minus A is equal to, this would imply this is equal to EJ, or EJ will be equal to root 2 minus 1 by 2 into A. EJ is known. Now once EJ is known, look at triangle EGH and EDC. They are similar triangles. EGH and EDC are similar triangles. EJ by EI should be equal to GH by DC. EJ by EI should be equal to GH by DC. EJ I know in terms of A, EI I know in terms of A, GH I need to figure out, and DC I know is A itself. This will give me a measure of GH. So from here I'll get root 2 minus 1 by 2A upon EI, root 2 plus 1 by 2A is equal to GH by A. This A and this A cancelled, this 2 and this 2 cancelled, or GH is equal to A root 2 minus 1 by root 2 plus 1. So now from this area of the segment, here, I have to remove area of triangle EGH. Area of triangle EGH will be half into EJ into GH. EJ is this much, GH is this much. So half into root 2 minus 1 by 2 A into root 2 minus 1 by root 2 plus 1 A. Now the wonderful thing for us is, before we proceed any further, you are told root 2 is equal to 1.5. Root 2 is equal to 1.5. So I can replace that and I can get it to half into 0.5 by 2 or 1 by 2. So this becomes 1 by 4A into 1 by 2 and 2.5. 1 by 2 into 2 by 5 into A. So this will cancel, this will cancel. I will get A square by 40. A square by 40. Area of triangle EGH is A square by 40. So from this, I have to remove A square by 40 and I'll get A square by 2 pi minus 2 minus a square by 40. So I can take a square by 2 out common, or I can take how much? A square by 40 out common. I'll be left with how much? 20. I will need to multiply this by 20. So 20 pi minus 40 minus 1. This much. A square I think there is some mistake in my working here. Pi a square by 2 minus a square. So pi a square minus 2a square by 2. Okay. Ah, huge mistake. Huge mistake that I've done. That renders this subsequent working entirely wrong is the mistake that I've done is here, this calculation. I found out area of the circle minus area of the square. I also need to divide this by 1 by 4. So from here, I'll get a square by 8 into pi minus 2 will be area of one segment. So from this area of one segment, a square by 8 pi minus 2, I have to subtract a square by 40. So this will become 5 times a square by 40 into 5 pi minus 10 minus 1, or finally it simplifies to a square by 40 into 5 pi minus 11, which is given in the third option. Okay. Next, in the figure not drawn to scale, ABCD is a cyclic quadrilateral, while triangle ABF and CEF are similar triangles. Which of the following cannot be the value of angle BAC if angle BEC is equal to 30 degrees? Okay. If this is a cyclic quadrilateral, this sort of circle will exist. Now, see this simple thing. If this is 30 degree and I bring it down, this angle here will be more than 30 degrees, because whatever this x was, let's say if this was x, this entire angle will be 150 minus x. So this smaller angle will be less than 150 minus x, because this is becoming smaller. This angle here has to be 30 plus something, 30 plus degrees. So with that in mind, just see, BDC will be greater than 30 degrees. This is 30 degrees plus. How much that is immaterial. It is going to be more than 30 degrees. And given that chord BC subtends 30 degree plus on the circumference, BAC will also subtend 30 degree plus. So the question which asks which of the following cannot be the value of angle BAC if MBC is equal to 30, the answer will happily be option A, 20 degree. Okay. Next question now. AB and CD are two arcs of the circle with center. AC is joined and extended to meet the line, which is an extension of BD at P. Measure angle CPD. So this AC gets extended here. This BD gets extended here. And they meet somewhere at this point P. This is external. This is external intersection of two chords AC and BD. So now in order to identify what is the measure of this angle, let's call this X. X will be equal to half the measure of arc CRD minus measure of arc AQB. So the angle subtended here and the angle subtended here. We need to find these out. So I have written it in reverse order. AQB and CRD have to be in reverse order. AQB and CRD. Here, the angle subtended at the center will be twice of 30 or 60 degree. Here, the angle subtended will be double of 45 degrees. So this will be 90 degree. So we'll have half of 90 minus 60, or we'll have half of 30, which is equal to 15 degrees. Next, this one now. Two circles with centers at 2 and P intersect each other at points A and B such that measure of angle AOB is 60 degree. AOB, this full angle is 60 degree. R1 is 21, so radius of the bigger circle is 21, and R2 is 7 root 3, radius of the smaller circle is 7 root 3. N and M, NM and QM are tangents to the smaller circle. What is the area of the shaded region? Now, in order to figure out the area of the shaded region, I need the area of this quadrilateral NPQM. From that, I will remove the area of this sector NPQ. Okay, let's figure out stuff. I know that because this is tangential, this is 90, this is 90, this is 60. So this will be 120 degrees. APB will be 120 degrees, which means NPQ will also be 120 degree. Okay, if this is 120 degree, I mean joining these 2 points. Now see, if this is 120, this will be 30. This will be 30. So ratio of length of sides will be 1 is to root 3. We are already told this is 7 root 3. This is 7 root 3. So length of NQ will be 14. Length of NQ will be 14. Now, remember, this was 90 degree, out of which 30 degrees here. So I have 60 here. I have another 60 here. I'll also have another 60 here. NQM will be an equilateral triangle with side as 14. With side as 14. So now if I'm looking for area of quadrilateral P and MQ, these are two triangles for which area needs to be identified. Area will be half into 7 root 3 into 7 root 3 into sine 120 plus root 3 by 4 into 14 square. This is the area of NPQ. This is the area of NMQ. So this gives me 147 by 2 into root 3 by 2 plus, here I will have root 3 into 196 by 4. So 49. 49. Okay, 49 root 3. I hope this is accurate. Okay. Or prior to that, let me do it this way. Let me keep it as 196 so that the denominator remains 4. So now 147 root 3 and 196 root 3. I will have 340 14 square 7 root 3 sine 120 is sine 60 root 3 by 2. That is fine. Half into 7 into 7 into 3, 147. This is fine. So this is root 3 by 4. So 749 root 3. This seems fine. 196 plus 147. So 343 root 3 by 4. This is the area of the quadrilateral. This is the area of the quadrilateral. From this, let me remove the area of the sector. Area of the sector, because this is 120 degree, it will be 1/3 the area of the circle. So 1 by 3 pi, how much? 7 root 3 whole square. So 147. 1 by 3 pi r square. This is the area of the sector. So from this, I have to subtract From this, I have to subtract 49 pi. I'm getting 49 pi. What is the error that is happening here? There has to be an error. Root 3 by 4 a square 1 root 3. The error is, of course, this. This is not 14. 1 root 3 will lead me to the side of this equilateral triangle being 21. This will be 21. This will be 21, which will lead me to this being 21 square. 21 square. 21 square is 441. So I'll have 441 plus 147. So 588 root 3 by 4, which will be equal to 147 root 3. And this is equal to 49 pi. So great. Area of the quadrilateral minus the area of the sector. I will reach my answer. Option B, 147 root 3 minus 49 pi. Okay. Next, in rectangle ABCD, M is the midpoint of AB. A square PQRS is inscribed in a circle such that it touches MD, BC, and DC. What is the area of the shaded region? Now, right now, I know this circle touches it here, touches it here, touches it here, but it does not touch MD. It only touches MD, BC, and DC. And that makes it very, very problematic, because had it been entire, then maybe we could have thought of something. But the fact that this has 3 points of tangency should give you this trigger. What if I went ahead and completed this triangle? Can I say, let's say this point being N, this NDC is a right angle triangle, and this circle is simply the in circle for that triangle. Then it would be nice. We know this is 8, so this base will be 8, and MB is 4. NMB and NDC are of course similar. If MB is 4, DC is 8, BC is 3, NB will be another 3. So this side is 6, this side is 8. This is a right angle triangle because this is a rectangle. So the hypotenuse will be 10. So the in radius can be identified very quickly. The in radius will be 8 plus 6 minus 10 by 2, which is equal to 2 itself. So area of the circle. Now, in order to find out the area of the shaded region, I need the area of the circle, which will be 4 pi. Area of the circle is 4 pi. And from this, I have to remove the area of the square. Now, area of the square, radius is 2, so diameter will be 4. Now, square is also a rhombus, square is also a kite. You can, of course, go ahead and find out the length of the side of the square, or you can do half d1, d2, half into 4 into 4. So cancel 2. Area of the square turns out to be 8. So, what is the area of the shaded region? From the area of the square, you remove the area. From the area of the circle, you remove the area of the square. Correct answer being option A. Next, if the areas of circles with centers O1 and O2 are equal, and that of circles with O3 and O4 are equal, then calculate the area of the shaded region of the shaded region if the radius of the circle with center O1 is equal to 7. Now here, you have to be very, very mindful. This is 7, this is 7, this is 7, this is 7. Great. Now, that means the radius of the large circle, has to be 14. Radius of the large circle has to be 14. Now, notice this small radius. This is what we are looking to figure out. Can I say this side of the triangle is 7 plus r? This is 7. What will be this length? This is the length that needs to be figured out. If I take this small r, radius of the small circle is r, this entire radius was 14, radius of the large circle. So this portion will be 14 minus r. And this is, of course, a right angle triangle getting created. So we'll have 14 minus r whole square plus 7 square is equal to 7 plus r whole square. This will lead us to the measure of the radius of the smaller circles. So we'll have 196 plus r square minus 28r plus 49 is equal to 49 plus r square plus 14r. 49 gone, 49 gone, r square gone, r square gone. We get 42r is equal to 196 or r is equal to 14 by 3. So now we know the large radius. We know the large radius is 14. So area of the full circle is 196 pi. From this, I can subtract two circles with radius 7. So 2 into 49 pi I can remove. And then I can also remove two circles with radius of 14 by 3. Area of two circles with radius of 14 by 3. So 2 into 196 by 9 pi. This will be our entire answer. Now, the first two will give me 98 pi minus 2 into 196 will be 390. No, yes, 392. 392. 392 by 9 pi. Now 392 by 9. How much will this be? So much effort. Right now it is leaving a remainder of 5 with 9. So let me add 4 to it. 396 should be divisible by 9. 396 is 44. So I'm doing roughly 43 point something. 98 pi minus 43.xx pi. Altogether we will get to 54 point something something pi. So the correct answer will be option A. If you're looking for precise answer, of course you can get to that. But otherwise also 54 point something something option A should be enough. Next question. ABCD is an isosceles trapezium with AB parallel to CD. A circle with center O lying at the in center of the median of the trapezium. 1 minute. A circle with center O lying at the center, not in center, lying at the center of the median of the trapezium as shown in the figure. AE and BF are perpendiculars to DC. AB is 8. This is 8. Okay. DC is 24. So if AB is 8, EF will also be 8. And given this is an isosceles trapezium, this angle is equal to this angle. These are perpendiculars. This is 90. This is 90. So these two triangles are supposed to be similar. What will be the ratio of their sides? 1:1 only. So this length is also 8. This length is also 8. This is great. And AI is 4. This length is given as 4. And GH is the median to the oblique sides. So if AE is bisected by this line in the same ratio of 1:1. So if this is 4, this is also 4. Essentially, ABEF is a square of side 8. This is known. Wonderful. Then find the approximate area of the circle enclosed within the trapezium. Great. Now see, this square is essentially inscribed in the circle. So if this is 4, can you see this diagonal of the square is equal to diameter of the circle? Diagonal of the square is equal to diameter of the circle. Now if this is 4, this is 4. And this is a square, so this will be 90. Opposite 90, if I have 80, here I will have 4 root 2. The radius of the circle is 4 root 2. And this entire portion is 1/4 of the circle. This entire portion is 1/4 of the circle. And this entire portion is also 1/4 of the circle. And this portion is simply the right angle triangle, which is part of the circle and also the trapezium. This blue portion is also part of the circle and also part of the trapezium. So we need measures of this. We need to figure out their lengths. So area of these two will be 2 into half into 4 root 2 into 4 root 2. These are the two blue regions, which will give me 32. This is the area of these two triangles. Now area of these two green portions, which is quarter of a circle or cumulatively half of a circle, will be half pi r square. R square will be 32. So I get 16 pi. So the total answer will be 16 pi plus 32. If I take 16 out common, I'll be left with pi plus 2. Or option B will be the right answer. Next. In the given figure, not drawn to scale, measure of angle AOC is 120 degree. O is the center of the circle and ABCD is a square. Find DP is to PC. We need DP is to PC. Okay. First thing I'm combining is this. Here I can see, okay, if the radius of the circle is R, this is R, AC, the diameter is root 3 by root 3R, 1 is to 1 is to root 3. So let's name this point N, D and C. In this triangle D and C, this length is root 3 by 2. This length is root 3 by 2. DB is, of course, the diagonal of the square. So this is also root 3 by 2. So side of the square, if I want to figure out, DC, if I want to figure out, DC will be how much? Let's see. Oh, root 3 by 2R, root 3 by 2R. Okay. I will have how much? DC will be root 3 by 2, root 3 by 2. So root 6 by 2 or root 3 by 2 into root 2. So this length of DC will be root 3 by root 2. This much length is identified. Okay. Finally, I need the ratio of DP is to PC. DP is to PC. Okay. How can I get that? Right now, I'm thinking maybe to this point, D to this point, and then this full length. Again, this is root 3R, this is root 3R. Everything is in terms of R only. Right now, if I take this length is root 3R, and this length is R, and this length is how much? Can I figure that out? If this is 60, opposite to 60, I have root 3 by 2R. This length, this will be 30 degree here. So this length will be half R plus half R plus root 3 by 2R. This is full length. Okay. Then how do I break that down? No. Does that help in any manner? Where do I make cuts so that this breaks down nicely? Not here. This is 60. This is R. All of that is fine. Oh, I can make it here. Look at this. I can make it here. I'm joining this center with O. How this will help me is, see, I'm getting rid of this root 3 by 2R from here. This is 30 degree. This is 45 degree because of DAC will be a right angled triangle, isosceles right angled triangle. This angle is 75 degree. Now OPC will also be 75 degree because in triangle OPC, OC is the radius, OP is the radius. So this will be 75 degree. So this will be 30 degree. This will be 30 degree. Now this DO would be the angle bisector. DO will be the angle bisector of AOC. So if this is 30 degree, this will also be 30 degree. So DP is to DC will be in the same ratio as OC is to OD, or DP is to PC will be the same ratio as OD is to OC. OD will be equal to ND plus ON, and OC is R itself. ND I already know to be root 3 by 2R, root 3 by 2R, and ON I know to be half R. We had figured out if this was R opposite to 90, if I have R opposite to 30, I will have half R. So root 3 by 2R plus R, this is OD, by OC will be equal to R and R, this, and this will also be equal to dP by PC. Wonderful. So I have to get rid of R's. I'll have root 3 by 2 plus 1. This is the ratio that I'm getting. Okay. Or the final ratio is root 3 plus 1 by, sorry, root 3 plus 2 by 2. But then none of the numbers here are aligning with that. Do I have to maybe rationalize? Okay, let me see if I rationalize it helps. Into root 3 minus 2. Sorry, but then I will get a negative number. So 2 minus root 3 by 2 minus root 3. So then I'll have 4 minus root 3 in the denominator. Numerator will be 1. Denominator will be 4 minus 2 root 3. I don't even have that. Oof. Root 2 is to root 1. I hope my breakage here is not wrong. And D is root 3 by 2R. If this is R, opposite to 60. If this is R, this is the entire thing, root 3 R. Okay, if this is R, opposite to 90, opposite to that will be half R. Here it will be root 3 by 2R. This will be root 3 by 2R. So this entire length is root 3 by root 2R, no problem. Or even this I don't really need anymore. This is root 3 by 2R. This is root 3 by 2R. Okay. Now OP and OC in this triangle, this is 75, this is 75. In OD, in DOC, OP will be the angle bisector. If OP is the angle bisector, because 75 plus 45 plus 60, this is the angle bisector, DP is to PC. Thought size, I think I'm on track. DP is to PC is equal to OD by OC. Now OD is equal to root 3 by 2R and half R. Root 3 by 2R plus half R. I think last time I recorded it wrong. And OC is equal to R itself. Okay. So this will give me root 3 plus 1 by 2. Root 3 plus 1 by 2. This ratio, dP is to PC, will turn out to be root 3 plus 1 by 2. Now, let me maybe rationalize this into root 3 minus 1 by root 3 minus 1. This will get me to 2 by 2 root 3 minus 1. Yes, 2 and 2 will get cancelled. So I'll be left with 1 by root 3 minus 1. Or option C fulfills the criteria. Okay. I hope you like the fact that I don't remove the portions in which I struggle, because that is very much a part of learning process. Next, in the given figure, not drawn to scale, BC is tangent to the circle at D, and AD passes through the center of the circle such that AD is to BD. AD is to BD is root 3 is to 1, and DC is 3. Okay. Find the ratio of area of AEF to that of ABC. Okay. Area of ABC is fairly straightforward. I've taken it as absolute numbers because finally the working that I need to do is simply this. What I finally need to do is simply ratios. So it doesn't matter if I take them as R or whatever. So I'm taking it as absolute numbers only. If this is root 3, if this is 1, this is the tangential point. So AB, this length will be 2. This length will be 2. Okay. Now if this is root 3, this is 3. 3 square plus 3 square, this will be 2 root 3. This length is 2 root 3. So now see, this is 90. This is 60 degree. This is 30 degree. Then this is 90 degree. This is 30 degree. And this will be 60 degree because of the ratio of the sides being 1 is to root 3 is to 2. So ABC, triangle ABC, 90 degree, 60 degree, 30 degree. Area of triangle ABC will be half into 2 into 2 root 3. This is guaranteed. Area of ABC. This is known. Now we have to do our work to figure out area of AFE. Now area of AFE, let's see. I can see, and something I can see maybe. I have this as 90. This definitely have as 90. AFE. AFE. Okay. So see, given that FE is subtending an angle of 90 degree here, it means FE is the diameter. FE is the diameter. If FE is the diameter, we know diameter AD was equal to root 3. So FE is also equal to root 3. Not just AD, FE is also equal to root 3. Does that in any way ensure anything for us? FE के लिए भी root 3 चल गया, AD के लिए भी root 3 चल गया. Now, I'm trying to ascertain if AFE or AEF, I can get one of those angles, then my life will be simpler. 90. I need AE या AF में से एक measure. Okay, I can do this. Look at this. BF, let me take it as X. If BF is X, FA will be 2 minus X. If BF is X, FA will be 2 minus X. And now, BF into BA will be equal to BD square. The tangent secant theorem again. So BF is X, BA is 2, and BD square is 1. So X is equal to half. So this is half. If this is half, FA will be 1.5. 1.5. Now, I have the hypotenuse, I have one side. I can go ahead and calculate AE using this. Otherwise, we can also calculate it as, let's say this is Y. So this will be 2 root 3 minus Y. And also, because CA and CD work, CD square will be equal to CE into CA. So CD square is 9 is equal to CE, which is Y, into 2 root 3. So I'll have Y is equal to root 3 gaya to 3 root 3 by 2. Y is 3 root 3 by 2. So now I have this is 1.5. This is 2 root 3 minus Y, no? So AE will be equal to, I have now AF is equal to 1.5 or 3 by 2. And AE will be equal to 2 root 3 minus 3 root 3 by 2. Or it will be root 3 by 2. This is now known. So area of triangle AFE will be half into 3 by 2 into root 3 by 2. So cancel. Sorry, why am I cancelling? This is area of AEF. Finally, I need this value divided by this value. Half into 2 into 2 root 3. Okay. So I can get rid of these halves. Then this root 3 and root 3 can get cancelled. These 2's will come down. Final ratio we'll obtain is 3 by 16, or option A will be the right answer. Okay. Next, let AB be a diameter of the circle. Break this down. AB is a diameter of the circle. Point C divides the diameter AB in the ratio 1:2. So A, B, I'm saying let this entire diameter be 12. So C, this is dividing it in 4 and 8. Okay. Let D be another diameter of the circle such that D is perpendicular to AB. So DE will go this way, D and E. What this does is it intersects at, let's say, O. So this is 2 and this is 6. Nice. Now we are asked what is the ratio of the area of DCE to the area of ABD. Okay. Area of the ABD and area of DCE. We are worried about this. We know radius of the large circle we have taken as 6. So DE will be equal to 12, which is diameter, and CO will be perpendicular to it. So area of DCE will be equal to half into 12 into 2, which is equal to 12. And area of ABD, again, AB is equal to 12, and this height DO, the height DO will be equal to 6. So we'll have area of ABD as half into 6 into 12. So we get 36 here. So the ratio will be 12:36, or final answer 1:3. Next, in the given figure, the two circles touch each other internally such that the diameter of the inner circle is 2/3 the diameter of the outer circle. Okay. So if I take again diameter of the outer circle, larger circle, I'm taking the diameter as 12. So this length here will be 8. So this radius here is 4. This is 2. And if this is 2, this is also 2. This length here, PR, is 4. Basically, the portions that I've written, lengths are known. Okay. CD, PA, and PB are tangents to the inner circle. Okay. What is the ratio of the areas of PMN and the smaller circles? Ratio of the area of PMN and smaller circles. Okay. And connecting these points. Hopefully you can see PAS and PBS are going to be congruent triangles. Now here, this is 90. But beyond this, do I have any other information? Yes, I do have an information. The radius of the circle was 4. AS is 4. And the hypotenuse is 8, which means PA is going to be how much? 4√3. 4√3 and 8 because of 30-60-90 triangle. Or let me not write 4√3 this way. Let me write it this way. This is going to be 4√3. Now, MA and MR are going to be identical. This, what is it known as? Tangents from an external point to the same circle will be equal in length. So MR is here. Similarly, NB, BN will be identical. Whatever work we are doing for PAS, same things would happen with PBS. Okay. Basically, see, area of the smaller circle that I'm certain of, that is 16 pi. Area of the smaller circle is 16 pi. I'm worried about finding out area of PMN. Now height here is 4, that I'm certain of. Base, I'm trying to figure out how much will the base be. I know this is 4√3. Now, Break it. Which side where? Hmm. Is there a way the angles break down in some manner? No. 4 into 12 has to be equal to 4 root 3 cube. That is fine. This is also taken care of. I need measure of MA and MR. If I find out measure of MA, my life will be good. Can I find out measure of MA in some manner? If I break this here, join this. This is 4, this is 19. This is some measure, this length. I don't know. So no, I can't break that there either. Or do I? No, no, I don't. I was looking at MRP and MRS being congruent triangles. If they're congruent triangles, then MAS and MRS are also congruent triangles. Ooh. Okay, look at MRP. MRP has a base of 4. MRS has a base of 4. The height is MR. The height is MR. So area of these two triangles, if I'm saying the area of this triangle is X, area of this triangle is also X. Now look at triangle MRS and MAS. Look at area of triangle MRS and MAS. Their area will also be identical. This is also X. So can I say area of triangle PAS is equally divided into three parts, X, X, X. It is equally divided into three parts. Same thing happens here, Y and Y and Y. Or you can perhaps write it down as X, X, and X only because the area would be identical. Now, the wonderful thing that I can do is for triangle PAS, I had all the three sides. For triangle PAS, I had all the three sides. I can get to the area there. It will be half into 4 into 4 root 3, which is 8 root 3. Now 8 root 3, I need 1/3 of that and I need to double it up. So 8 root 3 into 1/3 into twice of that will be the area of PMN. This will be the area of PMN, 2x's. And I need the ratio of this triangle's area with area of the circle, which is 16 pi. Which is 16 pi. So now I will get 16, 8 and 2 cancelled. Root 3 will come down. I'll have 1 by pi root 3 is the final ratio. Option D will be the answer. Okay. Next. AB equal to 12 centimeter is the diameter of the circle with center O. Okay. Huge circle. AB diameter 12. Fine. Another circle touches the given circle internally at P and passes through O. So there is going to be a circle like this passing through. So radius of this smaller circle is going to be precisely half of this. So this is 3, this is 3, this is 6. Okay. Now, if C is a point on the large circle such that AC is tangent to the smaller circle at D, C is a point on the larger circle such that AD is tangent to the smaller circle at D, then find AC. Length of AC has been asked. Okay. This seems fairly wonderful. See, this is 90 degree. This is also 90 degree. This is tangential. This is the angle subtended by the diameter. Both of these are 90 degree. This is the common angle. So AD, let's call this N. ADM and ACB are going to be similar triangles. Now for ADM, I know one side is 3, the hypotenuse is 9. Hypotenuse is 9, one side is 3, so this side length will be 3 root 8. 3 root 8, let me be sure, or 6 root 2. 3, 6 root 2, and 9. Okay. Now, AB is 12. 3 is to 4. So, AM by AB has to be in the same ratio as AD by AC. AM I know to be 9, AB I know to be 12, AD I know to be 6 root 2. So, AC, this is 3, this is 4, this and this cancels. So, we get AC as 8 root 2, or option C will be the right answer. Next, the largest possible square is drawn inside a circle of radius 6 units. An equilateral triangle is drawn inside the square with one of the sides of the squares as its base. The largest possible circle is drawn inside this equilateral triangle. What is the distance between the centers of the two circles? Okay. Very huge figure we have to take care of. First, we'll have to draw a circle. Then we have to draw a square within this. Center of the circle is somewhere here. Now we have to draw square within this. Square is made. Largest possible square is drawn inside a circle of radius 6 units. An equilateral triangle is drawn inside the square with one of the sides of the squares as the base. So now, this here will be the equilateral triangle. Okay. The largest possible circle is drawn inside this equilateral square. Okay. What is the distance between the centers of the two circles? Okay. First thing I know that radius of the circle was 6. This was 6. So side of the square, if this is 6, this is 6, side of the square is 6 root 2. Side of the square is 6 root 2. If side of the square is 6 root 2, then side of the equilateral triangle is also 6 root 2. So in radius, first I'm trying to figure out in radius of the triangle, in radius of the triangle. Equilateral triangle, height is root 3 by 2 into 6 root 2 into 1/3 of this is the in radius. 1/3 of this is the in radius. So this cancels this, makes it 3. This cancels this, makes it root 6. In radius is root 6. In radius is root 6. Now this length here is half the side of the square. Half the side of the square. So half the side of the square, I know side of the square is 3 root 2. Sorry, 6 root 2. So half of that will be 3 root 2. 3 root 2. So I can keep the length, the distance between the two centers will be 3 root 2 minus root 6. I can perhaps I can write this as under root 18 minus under root 6. I can take root 6 out common. I'll be left with root 3 minus 1. Or option C will be the right answer. Okay. Next question. In the following diagram, two tangent segments PQ and PR of length 12 centimeter each are drawn from an external point to a circle of radius 9 centimeter. This is 9. This length is 12. This is 90 degree. So of course, if this is 9, OP will be 15. OP will be 15. OP will be 15. But because OT is 9, TP will be 6. Okay. Next, what is asked? Who is the center of the circle? Segment MN, which is perpendicular to OP, touches the circle at T. What is MT? Length of MT is being asked. Okay. Look at this angle. This will be X. This will be Y. This will be 90 degree. This is X. This is 90. This will be Y. Now, I need measure of MT. MT is opposite to X. Opposite to X, I have MT. And opposite to X, I have 9. And opposite to Y, I have 12. And opposite to Y, I have 6. So MT will be equal to, sorry. This is where silly errors happen. Remember, MT was in the smaller triangle. So opposite to smaller triangle Y, I have 6. Opposite to Y, the larger triangle, I have 12. So this becomes 2, or MT will turn out to be 4.5. Option B. It is but obvious that MTS and PQO are similar triangles just because of the angles that are given. So I did not state it explicitly, but I'm hoping everybody who is solving this will catch on to that. Next, A, B, C, D, and E, F, G, H are two rectangles such that the points A, B, C, D, E, F, G, H all lie in a circle. The ratio of areas of the rectangles A, B, C, D, and E, F, G, H is 75:42. If AB is 15, AB is 15, and EH is 7. Okay. Find the area in square units of the circle that passes through A, B, C, D, E, F, G, H. First, let us just try our hand at drawing the circle that will pass through these points. Okay. I think I have done much better than I expected to, but okay. Now, this will be the center of the circle. Now, these are rectangles. So, the diagonal of this rectangle will be the diameter of the circle. Both these places. Now, I'm saying let AD be X. Let AD be X. Or let it be 5X, because we know the ratio of area is 75:42, no? 15 into 5X and 42X. So this be 7 and this be 6X. So look at the diameter, or the diagonal diameter, whatever you choose to call it. 2R whole square is equal to 15 square plus 25x square, and 2R whole square is also equal to 49 square plus 36x square. I can equate these two. I'll get so much effort. 11x square, this minus this, but then not 49 square. This is my challenge. No, not 49 square, 7 square. So it is already 49. So 225 minus 49, 176. Or x square is equal to 16, or x is equal to 4. Which means this is 24. Which means this is 20. Which means the diameter is 25. If the diameter is 25, radius is 25 by 2. So the area of the circle will be pi 25 by 2 whole square, which is pi 625 by 4, which is equal to 156.25 pi. Or option A will be the right answer. Next, in the following diagram, point E is on the extended side DC of an quadrilateral such that DAB is equal to BCE. This angle and this angle are identical. Okay. Point P lies on the interior of the quadrilateral such that PA is equal to PB is equal to PD is equal to 4. This is 4, this is 4, and this is 4. What is the length of PC? What is the length of PC? Now look at this is such a brilliant theoretical understanding question. If this is X and this is X, this will be 180 minus X, which means these two angles add up to 180. And given it is a quadrilateral, if this is Y, this will now have to be 180 minus Y. Can you see the opposite pairs of angles? The opposite pairs of angles are supplementary, they add up to 180 degrees, which means ABCD is now a cyclic quadrilateral. There will be a circle passing through these 4 points. Now, if there is a circle passing through all these points, that is besides the point. Now, look at this P. There is a point within the circle that is equidistant from A, that is equidistant from B, that is equidistant from D. There will be a circle that passes through all these points. My diagramming skills may not match up, but okay. There will be a, now there is within the circle, there is a point P that is equidistant from these points which are on the circumference of the circle. So what is length of PC? It is equal to the radius of the circle, or it is equal to 4 only, or option C is the right answer. That's it. Just you have to establish the fact that these points or this quadrilateral is cyclic in nature. Okay. Last question. A 1 rupee coin is placed on a table. The maximum number of similar 1 rupee coins which can be placed on the table around it, with each one of them touching it and only 2 others is. See how it would go down. If I can make, let's make 1. Let's copy it. Let's copy it again. Now, let's copy it again. This comes in later into our thought. See, 1 rupee coin, the maximum number of similar 1 rupee coins which can be placed on a table around it, with each one of them touching it and only 2 others. 3 coins will be in contact with each other. Can you see they have essentially made the centers of the circles, these 3 coins, if I join, I will have an equilateral triangle made. Now, if I want to introduce a new coin into the mix, again, a new such shape will get formed. Let me also create this. I will take it to the side. Can you see another equilateral triangle will get formed? And how long can I keep on going? Until I have placed coins all around this central coin. Until I have placed coins all around this central coin. So let me place that coin. What sort of shape will get created? If you can see that shape already, it would be very nice. If not, we will get there shortly. This is such a one. It's not like this is a novel concept. This has been tested in XAT earlier. So I should have done this. This is done. Okay. Now the next one would go here. And the final one will go here. See what sort of shape is getting created with n number of equilateral triangles. Clearly, a hexagonal shape gets created. Now, how many coins are there on the table? 7. But read the question very carefully. A 1 rupee coin is placed on the table. The maximum number of similar 1 rupee coins which can be placed on the table. So this coin is not to be counted. The new coins that you are adding, they have to be counted. Those coins have to be around it, with each of them touching it and only 2 others is 6. The idea of this comes from the shape of a hexagon, which is composed of 6 equilateral triangles. And that is the entirety of this sheet. Hopefully you learned something.